Testing, 1, 2, 3. Testing, 1, 2, 3. Got audio back. Yes, thank you, Chris. Thanks, Jeff Sachs. Yes, I see it on my meters now. So this actually leads into the thing that I was saying that you couldn't hear me say, which was it's been kind of a hectic past couple hours stream-wise. Life-wise, it's been a very chill weekend, which has been great. But I settled in this afternoon to like get some work done on the workbench and set up for tonight. And I'll tell you, it's not, I mean, all of the project stuff is going well. I mean, we finally have some tiny drill bits to help the Thomas couplers work that we'll unbox tonight. The couplers are working quite well. Like, things are going great in terms of the project, but I've been trying to get, you may recall from a couple weeks ago, I added this new Crappy and Crummy makes Crumpy. This new Crumpy webcam here to give us a shot of the microstage area. And like I say, it literally is like a $17 like Menards webcam. So thinking that tonight would be sort of the big culmination of the, you know, the little Kabuki drop project, I was like, well, it'd be nice if we could see it a little bit better. I've been meaning to experiment with this product from Elgato, who makes the Stream Deck streaming products and streaming lights. They make hardware for streamers, capture cards, and all kinds of stuff. They make an app that allows you to, in theory, use your phone, your iPhone, your Android phone, as a webcam, and it's very highly rated and seems to work pretty well for most people. It's like, well, you know, I've got an hour until this streamy thing starts. Maybe I can get that set up because, you know, I have a relatively modern phone, and all like any phone made in the past year, it's got like a really decent camera on it. Well, mine has a decent camera and a picture of my dog, but that's, you know, also like a lot of phones these days. I've been struggling with that for the past hour, and I just cannot for the life of me get it to work. I think it probably doesn't help that I have an iPhone and a PC, and they don't always play nice together. I don't have iTunes installed yet on this PC, which I know can be a thing that iPhones like to see when they get plugged in, because the Samba servers, for example, that iTunes includes, like, help you connect to your iPhone over USB. Any case, the project itself is going quite well. I'm just kind of frazzled by, like, I thought I was going to be in, like, this setup or that setup or the new camera. Yeah, basically everything's back the way it was. But that's all right, because it's worked relatively well for us in the past. Oh, but all this by way of making excuses that my wife and I, as we always do, did a lovely test of the stream. Thank you, Mary, for all your help, as always. And then, in the process of trying to get this all working, I rebooted the computer, and it clearly didn't turn the phantom power on my audio interface back on. Hence the no audio to start. So a rocky start, hopefully, like all things, means a smooth ending. And that's where I'm hoping we end up tonight. Here's what I'm hoping to accomplish this evening. Get the phone out of the way, because it's not doing me any favors tonight, it turns out. I have a curtain for us to drop in our Kabuki drop project. It's just a piece of a shower curtain liner that I chopped off and have about 18 inches of to play with. Mostly because it came pre-grommeted, and for tonight, for demonstration purposes, I like that it's see-through. It's got a little bit of like frosty texture on it, but mostly it's just see-through, which I think will be nice because we can actually see what's going on the other side of it if things aren't going well. So we have that going. We have just finished the 3D prints for the hooks. You'll remember last week we were working a lot on this hook design that will allow us to attach our curtain to our 3/16 brass rod using the Thomas coupler. I will start a second print. Thomas sent me a new coupler design to attach the batten to the servo motor. So we'll get a couple of those printed and hooked up, and then we'll do a big drop. That's the goal. I mean, in theory, all of these pieces should just work. But I thought it might be more fun, as we often do, to do the final assembly with y'all on camera. And, that way, if anything we discover, doesn't quite work, I can always lean on your smarter brains out there to help me come up with a solution. Or if anything catches fire, then it'll be, immortalized for the insurance company on this lovely stream. So, with that said, let me pull the Hook 3D prints off of the printer here, and I will get the Thomas couplers started. Just so those are they won't take but 10 minutes to print. But I've been this is the other technological shenanigans that's been happening today is I have been struggling with Fusion 360, which I'm assuming most of you are familiar with. But if you're not, Fusion is an incredible product and is free for hobbyists, which is a good reason to use it for nothing else. But part of its model is that everything is stored in the cloud. I mean, it's also stored locally, but pretty much anything you would want to do requires internet access. And I don't know if there's an issue with my internet or with Fusion or whatever. I could not get my installation of Fusion 360 to be convinced that it was not having connection issues for a long time today. And what I mostly wanted was to download this excellent new coupler design that Thomas sent me so that we could slice it and print it. And I finally got that to play nice in the last, like, literally in that last half hour as iTunes was finally, you know, trying to pretend that it was downloaded. I got the Thomas coupler to download as well. It's just been like a real chaotic last little bit of time in comparison to the rest of my very chill day. Here, let's print like 3 of these since we're printing them anyway. So this is the new Thomas coupler. We talked about it, I think, last week, but the gist of it is rather than being a 2-part design with a part that screws into the servo motor and a part that attaches to the pipe, it is all just one design. So we'll put the servo mounting screw down through there, and then we'll slip the pipe in the end. We'll drill through it with those nice tiny, these little crumpy, but hopefully sufficient little tiny drill bits, and we'll put some kind of peg through there to hold that in place. That'll secure the pipe, and then that'll be our coupler. So with 3 of these are going to take 13 minutes to print. I think we can stomach that. So that is exported. Let me grab the oldie flash drive. Yeah, I've got 2 different lightning cables hanging out of this USB hub because I thought maybe there was a cable issue with this camera. Let's see here. So let me grab my file here. Where did I export that to? Saved in as printed Kabuki Thomas coupler, we called that. As printed Kabuki. I know I've explained this before, but I know people do float in and out. I save all of my G-code files that I ever create, along with all the STL files, which is, you know, as opposed to just like putting it on the flash drive and taking it over to the printer, which maybe is silly, but every once in a while I'm working with a piece that I printed, 6 months ago. I'm like, oh, did I print this with, like, especially when something fails after the fact, right? It's like, did I print this with, 0.1 inch layers or 0.15 inch layers? I can't really tell. Was it adaptive? I can go back to the G-code file and do a little sleuthing and learn some things about the part after the fact, which is occasionally useful, although not always. Now, so I'm experiencing that thing that we all know and love, where for some reason, specifically the flash drive that comes with the Prusa Mini, this little silver flash drive, I have to insert it like 6 or 7 different times in the, flipping it 180 degrees each time before it will insert. Like, it's tradition, right, to insert a USB drive one way and it doesn't go in, flip it 180 degrees, it doesn't go in, flip it back to the first way and it works fine. For me, I don't know what kind of weird quantum superposition of states that this flash drive is in, but it takes like 5 or 6 times every time. Brother says you should get a Repetier hooked up to, or Octoprint. I certainly could and probably should. And honestly, if I ever end up transitioning the older printer to like a flexibles printer, which is sort of my dream for it, having a print server would be really nice. For now, this works okay. Chris has got a 13-hour print going. That certainly beats my 13 minutes. Chris, what are you printing for 13 hours? My God. That's awesome. Let's see. While that's printing, I'm sure there are other things we can do. Yeah, so let's do the threaded inserts in these little guys. It says it's nice to not have to get up to the desk to print something. I always have felt that, like, and I'm sure there are solutions for this, but, like, most of the time if I'm starting a new print, it's because I've just finished an older print. So I've got to get up and, like, take the thing off the bed and clean it out anyway. And at that point, I just grab the flash drive. History of what you printed and estimated costs. That's a feature I didn't know about. That would be super classy. Is that something that Octoprint... I have used Octoprint a little bit, mostly at work, but I have not... I'm not super duper familiar with it, like I say. Is that a feature of Octoprint or Repetier? Repetier? I have always assumed it's Repetier, but I guess I have no basis for that fact, or that pronunciation. Repetier has it? That's cool. Yeah, that's a nifty feature. Having a... So, I guess what I have right now is a history of files that I have sliced, but I don't have a history of what files I have printed per se. I'm gonna grab a threaded insert here. So I'm looking for M3. Oh, let me grab. I actually think yeah. So I think we said last time M3 by 3mm was the way to go, and give us some more clearance. Octoprint probably has a plugin. Yeah, something like that. I imagine something like that. Ooh, users can upload files and then you can have somebody else check it and print it. That would be very cool. Especially, so like, I think I mentioned before, we have a Prusa Mini at work that just lives, it's in theory, it's our department's printer, but it just lives in my workshop, which is all fine, and I use it. I'm the user of it 90% of the time, right? Just gotta get my soldering iron heated up over on the side here. But we do have some other users like my boss, a couple of our other technicians who have files to print on it occasionally. And so far, the workflow has been, sometimes they will slice it, but mostly they will generate an STL and then send it to me, and I will slice it and print it. But there's a couple people who I would trust to do their own slicing, especially now, since we've had it in the building for a little while. They've gotten, more fluent in the technology, and so they're more and more comfortable with that being a thing. But it'd be nice to have like a little check on everything. And so the idea of having like sort of a print server where they would upload it directly, and then I could confirm and send. Now with something like that, presumably, and Brookboth, I'm just going to lean on your knowledge, or Chris, or anyone else out there who's used these services more than I have. Can you, would they'd be uploading a sliced file essentially, and then you're reviewing it in like a G-code preview kind of thing? Repetti says upload both the model or the G-code. Oh, that's nifty. That actually would be quite cool, because often the thing I find myself being picky about with our other users is the slicing. Like I want to be, I think you should do this layer height. I think we should do, this one should be adaptive. This one should be, XYZ. So that's a really nifty option. Then it's just a matter of convincing our IT department to put it on our company-wide network so that we really could access it from anywhere. This is if you'll forgive me here, I'm just leafing through my bin of grub screws here, which is become entangled with the 3mm threaded inserts. We have a new IT supervisor at work, and if he ever watches this, hello, nice to see you. I think he's doing actually a really great job of bringing our IT into the 21st century, which is great. One of the challenges for our department is, so he, I believe, comes from a hospital environment in the past, so he's incredibly security-minded, which is great. Like, he really wants everything to be, locked down and on its own VPN and not give anything more. The default is you don't get access for your, for any device. And then if you can demonstrate that you need access for your computer, for whatever, then you get whitelisted for whatever it is. And that's a great model, right? That's a solid security model. I need to do a better job of aligning this threaded insert here. What was I saying? Oh, but one of the challenges is that, we're a science museum that has, computers dating back to, gosh, the 90s at least. There are some Windows 95 machines running. I'm trying to think. I want to say, well, so we still have some DOS machines running in the circus exhibit, and then I think those are the only DOS machines still, because I've eliminated the DOS machines that were running the 727, and I don't think Genetics has any. He said, thinking out loud, but. So our new IT czar, very understandably, does not want these, Windows 95 machines exposed to the contemporary internet, especially when we're afraid of applying, updates at any, or they may, who knows what's going to happen. We need to preserve this software as running, so it needs to be siloed from the internet in a pretty significant way. So something like an external bit of software like a 3D print server might be a little bit of a hard sell. In some ways, I wonder if Repetti would actually be a better option would be an easier sell than something open source like Octoprint, just because, a price tag can communicate confidence to management sometimes. Hey, Cookie, good to... Cookie, listen, if we ever were going to vote, and this, by the way, we won't, because this is an awful idea, but if we were ever going to vote whether there should or should not be fire, if that was the vote, I would feel fully confident proxying your vote for fire, Cookie. Forgive me, but I feel like that's a sensible summary of your viewpoint. There we go. Yeah, there are certainly like having a company behind a product, even just like having a really decent web page can be really good for selling a product idea to management, right? Like, and I have been this person putting up open source projects with minimal documentation and a blank white web page with like a media wiki install with almost nothing on it. Like, these things happen, but when you're trying to instill confidence and say, hey, this won't, break or crash our multi-million-dollar institutions network. Sometimes even like a company that's charging for their work and, gives you a flashy web page to look at. Sometimes that's, even if the product is worse, there are advantages to having a company that stands behind their work. But we shall see. I grouse about our IT management because that's my prerogative. I really do think that our new IT folks are taking some necessary steps to bring our IT security up to where it needs to be, considering the size of the institution and the amount of technology we're using. Where was I going with that thought? It's gone. It's absolutely gone. It was a great introduction to a sentence for what? Something about computers, something about technology. They're doing quite well. Oh, I know what the story was. Okay, so one of the things they did so we were, shut down for COVID over the holidays again, which was a bummer, but IT staff took the opportunity to hire a pen testing company to try and infiltrate our network. I believe purely digitally. I think this was not, I don't know, but I think there was not a physical pen testing component of this alongside it. Partly because doing a physical pen test while the building was shut down and while normal staff and normal operations are not there seems a little silly to me, so I don't think that's what happened. But they did a digital pen test. They basically turned on all of as many devices as they could, knew how to turn on. They actually brought in a couple of my colleagues while we were shut down to turn on everything that could potentially be connected to the museum network or the outside internet or anything like that, and then sort of gave free reign. I was not involved in this. There's an after-the-fact story that is the only reason I know about it. So I don't know exactly what the scope of this testing company was, but in their report after the fact, was basically like, how much access could you get to our network, our servers, our various network-attached storage devices? Like, how vulnerable are we? And the report came back and said one of the primary points of access that they found onto our networks was via one of our exhibit installation pieces of hardware. So we have, at the Museum of Science and Industry, and maybe I will... Let's see, you're looking at that monitor. Maybe I will do a quick, while the Thomas couplers finish printing, and since we have our 3 hooks already sort of lined up here. Hey, speaking of the Thomas couplers, how's it going, Thomas? Good to see you. I was just saying, well, I'm printing out a batch of the newest coupler that you sent me just now. They'll be done in a couple minutes. But while those are finishing, I'll tell a quick story of network security. While I do, let me see if I can just find an image of this, and you're looking at a different monitor than I am. While I just pull up a web browser, Museum of Science and Industry, Apollo. Just Googling images of my own. Yeah, okay, so here, let me pull this up. Open image in new tab, and I'll bring it over to where... Here, there's nothing secret here. We'll just bring us over to there. So this exhibit that had this network fit, Dave. I do too have quick stories. I think I have quick stories. I'm not able to tell them quickly, apparently, but I have some. I think. Which reminds me, a quick story about what I'm drinking tonight. Tonight's beverage is a Be-All Hazy Pale Ale from Solemn Oath Brewery. They have a Be-All and an End-All that are both hazies. Very delicious, smooth, not super hoppy, which is interesting for a pale. I guess it's not an IPA, right? It's just a pale ale. Very good. If you're drinking something interesting tonight, always curious to know. Water, always a good choice. So, where was I? Oh yeah, the middle of this short story. This is a decent picture of it here. You can kind of get some context for it here. Oh, with an awful picture. So out in the Henry Crown Space Center at the museum, we have a lot of fun things, including the Apollo 8 capsule, like the actual Apollo capsule that went to space and came back down. It's on permanent loan, I think, from the Smithsonian. Really beautiful thing. But one of the other cool pieces of technology we have is this guy. And I wish I had a better picture of this, kind of low resolution. Let's see. I'm literally just doing a Google image search here to see if we can find this thing. What it is, here, this is pretty decent. Yeah, no, that's something else. It is an actual training module for the lunar lander, for the LEM. Yeah, this is a pretty good picture. That Apollo used to train the astronauts in the basic functioning, the location of the switches and things like that of the lunar module before they sent it to the moon. So this is an actual piece of NASA hardware that is now sitting in this, big diorama in this pit in our museum, which is super cool. Part of the this up here, you can see my mouse there, yeah, up here in the cabinet itself, right? We would love to give people the experience of what's going on inside, because the NASA engineers just built the outside of this thing out of plywood and some paint, right? It was just there to like, hey, it's not meant to be a realistic exterior model. The point is that buttons and controls on the inside of this thing match their locations in the actual lunar lander. Super nifty. But of course, it's an actual artifact. It's an accessioned artifact. We can't just like have guests literally climbing this ladder, which is still coated in that like foil. I guess it's just gold foil up the steps and into the thing. So what we've done is installed a little PTZ, a little pan tilt zoom camera inside the ceiling of the module here, and we have a little station off to the side where guests can, with a joystick and a couple of zoom buttons, can basically look around and explore the interior of this cabin without having to actually go inside it. And that works really well. It's actually, I think it's a really cool exhibit. And as one of the few people who has keys to the lunar module and actually gets to go inside of it, I mean, being inside of it is really super cool, but the camera does a really nice job, and it allows you to like, zoom in really close and see like the original labels on things. You can find like the various, abort sequences down to like where the food was stored. Super cool. This camera is a not very fancy, Dave, you're right, it's not a short story. This camera is not a very fancy PTZ camera. It's like a, IP camera. I think it's basically a security camera, right? You plug it into your Ethernet DVR, and it's meant to, so you could look around your building's hallways and keep things secure. And the point of this story is that network security-wise, it's a disaster. It basically was open on all ports, beaconing out to the universe saying, hey, I'm a Wi-Fi camera, please connect to me with no password, I'd like to be connected to. And this is one of the primary ways that this pen test, remember the story was about the network pen test they did while we were closed in the winter? Is one of the primary ways that the pen testers found their way onto our museum network. Which is not surprising, like these sort of, lower quality PTZ cameras are not known, and all lower quality network devices are not known for security. So one of the things I've been tasked with is to figure out what we're going to replace this thing with. The first thing I think we're going to do is just replace its I'm going to take it off the museum network, right? We already have, it's down. But maybe put it on its own small network so that just the camera and the interactive surface, play nice with each other, and then figure out something longer term that's a little bit more stable. QLib can be a decent thanks to OSC and script queues. Yeah, anything that could run OSC, or I don't recall. I've done a little bit of QLib programming with like its Apple script interface essentially back in the day. I don't know how much trouble you could get into running. I think it's native Apple script via QLab script. That seems like a maybe a challenge. Let me see here. So anyway, that was the that was the long version of the short story, which is our exhibits, by their nature of relying on not cheap parts. We have money to spend on doing things decently, but even like a really decent PTZ camera, it can be thousands and thousands, $7,000-8,000 easily. So by using an $800 one when this was installed 10 years ago, we've left ourselves a bit of a security hole. So a challenge to be overcome. Speaking of challenges to be overcome, let's get our Thomas couplers off the printer here and do some Kabuki assembly. That's what you're all here to see, at least. Well, all of you except Cookie, who is here for Flames. And Cookie, no promises. Although I did reconfigure my power supply for the microstation tonight, so we'll see if that causes any issues. Let's see here, what order to do this in. So I think let's rescue the... I guess I don't really have a name for this yet. This unit that is the servo... The tippy unit, the brains of the operation that just holds the servo that does our control. Let's zoom us back out a little bit here. So let's get our new Thomas coupler installed here. There we go. Make sure I didn't lose them already. Good. Let's grab our Phillips head here. Oh, right, and this is just a press fit, right? The first generation Thomas coupler was just a press fit one. A 13-minute story. Chris, yep, nope, I have no comment. That sounds about right. All right, so the new Thomas coupler, right? So the old one that I just took off, as I mentioned earlier, is a two-part mechanism, right? So there's a part that goes onto the servo horn and a part that goes around the brass rod, and they would couple together with these little sort of dovetail-like joints. But after last week, Thomas did a mod to them so that it's just a single-piece design, which I have not tested yet, because like I say, it's always more fun to do the testing live. So let's see how it goes. We can always, for the sake of getting the drop tonight, we can always go back to the older generation Thomas coupler. I'm going to need one of our little screws. So I have actually, these are the wrong kind of screws. These are the servo mounts. I need the little tiny screw that goes into the servo horn mounting itself. Oh, Chris makes a good point, right? So one of the things I realized, I have not revised this 3D print at all in the past few weeks, right? But one thing that I thought would be nifty would be to mount the control PCB in the base itself. And that would just be a matter of like reimagining exactly. Like this is just sort of two existing 3D prints chopped and screwed together. And so being a little bit more clever about would allow us to put them in the same thing. So good point, Chris. This is probably not the last time we see this. All right, now thread. You know what I'm going to do? I'm going to take the coupler off, and before I try and put the screw in, this just like last time I have some fouling down the center there. So I'm going to just take just a little Allen wrench and just poke that out. And that's just because I printed this, it's without supports, it's going to have a little fouling, and that's fine. Take this guy, we'll just poke it right down, just so the screw isn't trying to screw through that. There we go. That's better. Clear a little of this out, too. I mean, certainly, Chris, there will not be, this is not the final time we will see or work on the Kabuki drop. One of the things I mean to do, right, is have a more interesting and colorful curtain, or maybe it's an all-black curtain, or something like that. So it will continue to be a part of things and continue to be improved. I just think tonight will be, let's call it, not the culmination, right? This is going to be where we... hopefully get to see the full-scale drop in action. You know what else I should have done before screwing that in place was get this... Oh, that went in pretty well. So that's going to be... This is our batten. This is actually... I reused that batten that we glued the first-generation coupler onto. I remember we super glued it and then hot glued it, and I couldn't actually get it all off. So that's just going to be hanging out on that end. Because this happens to be a really nice length of batten for the experiments we're going to be doing. So now what I'm going to do is punch the hole in this batten right through there so that it stays in place. So let me grab, I'm going to grab my drill, we'll get set up. I'm going to mute my microphone while we're actually drilling because I think it's going to be pretty horrific. I guess I don't know, I haven't tried it yet, but I can't imagine, you know, but the microphone is attached to my chest. The drill is about 12 inches away. I think that's not going to quite be the vibe that we're looking for. So I have a Tool Shop branded cheapy set of tiny drill bits from Menards. I have a nice set of very small drill bits, like number 70 to 80 in here with my pin vise. But I wanted something I could chunk around a little bit more. So let's see here. Mostly, this was like a $4 set of things, and if I end up using them a lot, I will invest in a better set. But I mostly wanted something to get us going this week. Let's see here. I think so. This is, I believe, a 2mm diameter hole as designed, which probably means that the print itself is a little bit smaller. So that looks like a decent drill bit there. Get the holders on before attaching the servo. Oh yeah, I could do this. I could do this on the bench without it being in here. Although honestly, having it held by the servo there is a little bit useful, just as work holding. Oh, right. But I have to, Chris. I think I have to put. I have to get the hooks on, right? Yeah, because the hooks slide in from the end. Good catch. All right. So just like last time, I have not adjusted the tolerance on the holes in this, so I'll probably have to do just a little bit of filing to get the hooks to go on. Oop, that's not my rat tail file. Did I put it away? Maybe I did. Here's my file set. Yeah. Just want my basic round rat tail file. Just to take like a little, yeah, exactly. Yeah, thanks, Chris. Good catch. All right, we'll just give that a quick once over. So I'll thread the first one on, and we'll have to figure out where in relation to each other these hooks go based on the spacing on our curtain here. Oops. So we're gonna have one on this side, and then it looks like, oh, this is actually gonna be just a little bit, be kind of the perfect length. So I have one there, we'll have one just left of center, and we'll do one right at the far end here. That means there'll be a little bit of fullness in our curtain, but I think that'll be okay. So that means I need one hook here, and I need two hooks on this section. So let me take this painter's tape off. That was also a remnant of our experiments last time. There we go. All right, we'll get that one hook on, hopefully, and we'll get the other hook on in the correct orientation, I hope. Yeah, good catch, Chris. See, this is why I mean, partly for the joy of it, but this is another good reason to do these things on stream, is because like I get so wrapped up in the excitement of doing the thing that, I mean, as y'all who have been here for a while know, order of operations is not always my strong suit. So good to have somebody else who can watch and be like, hey, you forgot to do a thing. All right, so all three of those hooks are on now. I'm going to leave the final placement of them until this is assembled. But now I think I am ready to punch some holes in this thing. So tighten that drill and get that arranged. You know what I'm going to do? I think I can have an arrangement here that will make this a little bit more stable. Just rotate that upward. There we go. And like I say, I'm going to mute myself just for the drilling part. You can listen to enjoy the chill vibes in the meantime. And we're back. Okay, well that was pretty painless. I mean, brass is relatively easy to drill. Now what I need is something to pin this together. And there's a lot of things we could use, but what I think I'm going to try first is just a little piece of soft copper wire, because I can kind of bend it over to act like a little, kind of like a cotter pin. Which is basically what this is, right? It's not actually being a mechanical support, it's just to pin this coupling in place. So here I can get us a little closer to the action. So let's just gonna pin this so we don't run out of alignment, and we'll rotate that over so we can see what we're doing. And now let me grab some pliers here. And we'll just bend 1 and 2. And we have basically our little cotter pin. And I'm actually going to just leave it like that. It's not super tight, but I think that's okay. Because all we want it to do is when the rod rotates, or the coupler rotates, we want the rod to go with it. Ooh. Although now, I can feel we're slipping on the servo. Which is something I'm going to have to take this pin out to rectify. Maybe I didn't tighten that screw enough. But I can feel the plastic of the coupler slipping on the gears of the servo itself. So let's pop this rod back out. I'll have to get that back in alignment in a little bit. All right, so that screw is now a little bit tighter than it was, hopefully tight enough. I'm also being, I mean, I think my, like, probing and testing is a little bit more aggressive than the actual forces it'll encounter in use. Chris says, did the screw loosen up? I'm not sure. I mean, certainly I got maybe not quite another quarter turn out of it. So either it loosened or maybe I didn't do a great job of tightening it to begin with. All right, so I got 2 more holes to do in this center coupler. So I will do those next. And as before, well, I guess first, a little refresh. And second, I'm going to get myself set up here, and then like before, I'm just going to mute my mic just for the sake of, I mean, I don't know how bad it is out there, but I can't imagine that is terribly pleasant to listen to. So a little mute. All right, there's one hole, and I'm going to pin that in place first. Jeff Sachs does not mind a little light drill sound, which I appreciate. Let's see. Chris is having a aberration of light by Riverlands. Well, that sounds very tasty. Aberration of light. That's a name. Makes me think of, I'm a big fan of listening to books on tape while I'm doing physical work, you know, soldering or circuiting, or, you know, I'm moving things around the museum. Like I have audiobooks just like on tap for projects. And recently I've been listening to a lot of Terry Pratchett because I find his humor and Douglas Adams' humor and things very, very delightful. And something about aberration of light, just like, this sounds like a Pratchettian idea to me. I might have to redo that pin. That's gonna fall out of there, I think. But let me do this last hole, and then we can. All right, that should be our last hole drilled for a while. Let me get a slightly longer bit of this soft copper here for our last pin. Oh, Thomas makes a good point. Yeah, the plastic, whatever I don't know if we ever decided what that plastic was on the servo mounting point, but you know, if it's Delrin or PTFE or whatever it is, like we could have easily have just worn it down because we've been taking stuff on and off of it for the past 3 weeks. So that would also make some sense. All right, so that is now pinned, and this is I'm gonna redo this second pin here. I was like, oh, I have a little bit of copper wire left. I can make that work. Let's just do it right, because that'd be a really silly way to have a failure. Yeah, it could certainly do super glue. I've got like a little bit of, I could do like thread locker, or you know, like a medium weight adhesive. But we'll see how it holds up. I think I've got a good feeling about it. So I have a little bit of play in this joint. which I might decide to stiffen up a little bit. I mean, it's not going to go much more, but partly my pin is slightly smaller than my hole, so you can kind of see the two sections of this batten rotating in relation to each other. But again, I think a problem to be dealt with when we have it. So it's going to take a quick second and brush the brass filings off of the workbench here, and then we can carry on to setting these hooks in the proper orientation. Let me zoom out so we can get a little bit broader view there. So let's get our curtain up here, our fancy pants shower curtain kabuki drop, and we'll start getting these aligned. Oh yeah, we're gonna these kind of stretched right to the end on this. I can zoom out even a little further. The batten is just about right for the length I have on the microstage itself. It's a little bit short for this, what happens to be the the grommet spacing on a shower curtain. But maybe that makes this easier, right? So I can just set these in kind of any position. Oh, you know what I should do, though, is I should power this servo back up and get it in an appropriate orientation before we lock those hooks into place. So let me get my... This is one of our little Demilight control boards. We'll plug that back in. And I've got that hooked up to a little mini light board off to the side here. So I think what I want, I'm not entirely sure what's going to be best, but I'm going to say let's just start with it centered, just there. Let's think through this. So this is going to be, as I look at this from above, this is going to be its orientation. So let's say, excuse me, let's say centered wants to be. So really, oh, you know what would be nice about this is we could orient the hooks such that their flat side is parallel to the flat side of this base. That might not be the easiest thing to set up now that I have the base already put on, but that's a kind of decent approximation to the orientation. I'm going to slide this hook all the way to what will be the stage right end of the batten. We'll tighten that set screw down. I'll slide this other one. Now, I'm not going to be able to do it where you can see it because of where the camera's pointing, and because this base is now lower than this pipe, I have to hang this off the end of my workbench to get the hook to sit flush to the table, so we make sure that this alignment is correct. But you're not missing a whole lot. You're missing me tightening a set screw, and I swear it's going to look a lot like the one that you're about to see. All right, that's pretty tight, and now we'll do this middle one. And that middle one, if these were... Oh, I should have checked a position on this as well. Slide that right over to the end there. All right, and now this middle hook wants to be basically right up against this coupler. And again, so you'll recall for those who were here last week, we decided to put a flat side on the sort of the upper part of each of these hook prints, so that by putting, say this hook is already attached, by putting the flat of the new hook down flat to the table, we can make sure that they're in the same sort of orientation with respect to the pipe. Now this one's proximity to the coupler is actually making that a little bit tricky, just because the coupler makes it want to, stand proud of the table surface. So again, I'm sorry I have to do this off camera in a place where that can hang off the edge of the workbench. But I can describe it in great detail. So I'm using a hex key and I'm tightening a screw and it's going into the hook and ta-da! So there's our 3-hook mechanism. Oh, let's see, let's zoom us out there. So that's our 3 hooks on our kabuki drop. Let's give this another quick spin, and then we'll get it mounted and we'll see how it does. All right, so there's our mechanism, and if I run the 13 minutes later, we have the description. Yeah. Why are you not? I was doing this earlier too. Something is screwy. I think with my DMX connection. Something I think in my wiring is screwy here. So I'm just having a look at the connections. Well, let's see, let me just bring this over where we can actually see it. So this is one of our little Phoenix connector blocks that I think is giving us trouble. Let me grab my 3/32 flathead here. Just make sure that all of those are tight. And I'm not sure, it doesn't seem to be getting intermittent power because the little power LED on the control board is staying lit. And yet when I run the control back and forth, I only get intermittent movement, which is odd. So what have I done? What have I broken this time? Sir. It's got this weird jerky motion. I'm gonna unplug my DMX source off camera here and see if the motion goes away. Right, and if it does, and it looks like it has, I think that means that the problem is DMX source related. That could do it. So let me pull, oh, no, it's still going. So maybe it's power related? Oh, yeah, I think it's power related. Here, let me unplug my power strip. I think what is happening. So one of the things I did, and I should have thought of this. Let's see if I can show you. I can show you on this camera. So I have one of our little, power splitter boards that has the 4 places for a Phoenix connector and also has these big terminal blocks. I'll pull another one out. This one is currently wired into the system. But shortly before the stream, and I should have suspected this because, it's the last thing that I changed, I moved this board, which I had been running on my bench power supply. I moved it over to the same 12-volt power supply that's powering the LEDs above the 3D printer and such, just so that because the data is running that way anyway, I thought it would have one less pair of wires running haphazardly across the workbench, which was a good idea. It is a good idea, but I think I did this connection poorly. I think it is getting intermittent power of a sort. So let me redo this connection here and get my larger Phillips head. And I know, so again, this is a third thing in a row. It's I swear I'm doing something, but not where you can see it. You didn't want to see things on YouTube, did you? That would be absurd. So now that that's done, I can plug the XLR to Phoenix adapter back in. And I can plug the long 4-pin cable that runs to the lights back in, and I can plug the power supply back in, and we're not muted, and it's going great. And we still have intermittent twitchiness. But why? Huh. Curious. So let's see, let me think through what else has changed. So we had this working before the stream over in the microstage area. So what has changed from there? I'm thinking, so this is, as I've said before, part of the process of thinking through troubleshooting is what has changed since it last works? So that's kind of where my brain is now. Well, we can start going through this more systematically if this doesn't work, because I really would love to see this Kabuki drop tonight, including things like checking power. We'll check signal, things like that. Just looking for anything obvious. Did I miss a solder joint on the servo motors? I've definitely done that before. Ooh, that buck converter is screaming hot. That's not a great sign. Huh. What is my input voltage here, I wonder? I'm not like Cookie get excited because Jeff's burning himself hot, but hotter than I would have thought for a buck converter. Maybe that's the issue. Maybe I just need they are, to be fair, 60-cent parts that take about 4 weeks to get here. So if one of them was bad and faulting, I guess I wouldn't be entirely surprised. Yeah, yeah, it was gonna be so simple, Thomas. It was gonna be so So straightforward. You plug everything in, it just works. And, I mean, all the things that were, like, new tonight, like the new hook design, the new coupler design, are working great. It's just a question of, like, getting ourselves over the finish line here. So let's see. So I'm getting 12 volts in, which is what my power supply is, in theory, putting out. Let's look at our output voltage on our regulator is 5 volts solid. I mean, it is warm. You know what we could do to verify that it's a power supply issue is we'll power it. We've done this before. We'll power it off of our programming adapter, which just gives it 5 volts natively, and see if we have any twitchiness with that. Now, of course, we won't have DMX in this case, but what I could do is unplug my 12 volt supply and we'll route DMX back into it through this connector, and we'll see. Yeah, okay, so that's good. So now I'm just running the fader up and down on my board here. Much more smooth. So yeah, so I've got some kind of a power issue. Like my regulator is maybe browning out when it shouldn't be. That's kind of worrisome. Well, I think what let's do... Oh, everything's still okay? I think we're okay. I heard the sound of a... Oh, I think it's the adapter here. Whenever I hear the sound in my ears of a USB... like a Windows detecting a USB thing disconnected, I'm always like, okay, I have like 70 USB things hooked up here. I've got the cameras and the microphones and everything. Is this a disaster? No, I think it was just my serial adapter there coming unplugged. So, I guess, how do we want to fix this? I mean, for the sake of tonight, we could just power it off of 5 volts. It would be nice to have this actually working. So maybe I will just real quick replace this this buck converter, just so we could leave this in place more permanently. So let's get out a friend that I haven't used in a while, actually. And in fact, I don't know where it is because it's not on its little hook on the wall, which is my PCB vise. PCB vise. Oh, there it is. I'm gonna say I abandoned it for so long. It got lonely. Walked away. Went home. But we'll just desolder this and put a new. Maybe we'll put a fancy like $1.50 regulator in place. Wouldn't that be fancy? Maybe not. Let's not get carried away. We'll use our solder wick to get the bulk of the solder off. Now, I should have switched to a chisel tip. I've still got the pencil tip on from when we were doing the threaded inserts, but I think this will work well enough. So we'll just get the partially because we're going to have a hard time getting too much heat into this with the pencil tip. Just going to get a little bit of the excess solder off using my solder, my braided solder wick here. Oh, Chris Wick says that solder wick is his distant cousin. Chris, you're killing me here. You're murdering me dead. Brookbooth says, Brookbooth, let me get this heating up, and I want to read this thing you've written. Brookbooth says, just got another Pi Zero so I can build another one of my Q lights. Oh, I remember this. I'm going to have to build my own version of Raspbian to make it easier to install. Thankfully, the build tools are open source. You know, I don't know, I was just listening the other day to Embedded.fm, the Embedded Development Podcast with Chris and Alicia White. And they were talking about they had a guest on talking about the various flavors of Linux build tools, which was fascinating. I constantly, realize just how much of the ecosystem of those operating systems I take for granted. Wow, this is not going to want to come off, huh? I may need to switch to my stouter tip after all to get this ground pad to play rice. Well, one thing we could do is just and we'll put a little extra flux on there to help this flow. Let's see here. All right, let's give this one more try. Let me put just a little solder on here. Maybe I'm having conductivity issues. Whoa. We'll get a little solder on the end of the iron there, just to help the heat flow into those pads. Oh yeah, that's helping some. Try not to melt my vise too much. Whew, there we go. That's fine. Just a little burn. All right, let me grab another of my 5-volt buck regulators, which I think I put on. So like as y'all recall from Demilight 0.94, for which the assembly line guide is still online at jeff.glasses/Demilight. I believe I put a link to the actual buck regulators that I use on there, just because they seem to work okay, although maybe I should revise my opinion in light of this particular failure. But if this one also fails, I guess we'll cross that bridge when we come to it. But what I started with was a more expensive packaged product from DigiKey, but the concept behind all these, right, is it's meant to replace a 7805 or a 7803 or what have you, depending on the model you get, to be a drop-in buck converter regulator. Although I think they also, try to remember, I think they make buck boost regulators, although maybe not in exactly this form factor. So you say, I want 5 volts out, and you can put anything from like 3 volts to 24 volts. These ones are buck only, right? So you have to put in a higher input voltage, but that's typically not an issue since we're trying to push current over a distance. Higher voltage is preferred anyway. All right, well, that is now reattached there. Let me banish the PCB vise back to the depths from which I found it, aka under my workbench. And we'll plug this back into, well, okay, before we do anything else, let's plug this back into regular old 5 volts. And we'll just make sure that I haven't broken anything further, and then we'll test it on 12 volts again. All right, there's 5 volts, and we'll get some DMX into it. There we go. It's DMX, and there we go. Yeah, so that's working fine. So now we're going to take the 5 volts away. Ah, cool. Cookie's thinking about doing a first board layout as an adjustable buck converter. That's very nifty. Yeah, I mean, so as y'all who have been here for a while know, like, I am not an expert in PCB design or fabrication, and part of the goals of this project were to learn a lot more about it, and I think that's been very successful. Oh, you know what could be happening? Well, let's see how this goes. Yeah, I think there is something. So I've switched from my bench power supply, which is a regulated power supply, a linear power supply, to a cheaper, like a 12-volt Meanwell power supply. Maybe you can see it here. Yeah, it's just this big silver thing stapled to my wall. And I wonder if the interaction between those two things is not playing particularly nicely. Because this is the first time I have seen this issue. So maybe we need to go back to the other power supply for this evening. Like, I wonder if there's something about trying to run this buck converter, which is a highly reactive load on this cheapy 12-volt power supply, that the buck converter is not particularly happy about. So, while I've got this power supply unplugged, we're just going to remove the 2 wires leading back to my power breakout board, and we'll run them back the other way across the desk to my bench power supply. And if this works, then I don't know what. To figure out a different power supply. This is actually, so this would be, are the grounds connected? Just a 2-volt supply, Chris. I guess 2-volt supply to the device. You know what? I didn't label which of these is which. Very good. This is negative. Although I do have reverse polarity protection on the Demilight boards, so that wouldn't be catastrophic. There we go. Okay, so now we're back on the lab power supply, and this works fine. Wow, that's super weird. Huh, I wonder what it is. That merits, actually, quite a bit more investigation. Not tonight, we're going to move ahead with the Demilight, or the Kabuki drop, but that is a weird one. Like, what is it about the interaction of a, you know, admittedly incredibly cheap buck converter circuit and an admittedly very cheap 12-volt power supply that's causing the buck converter to fail? And this is back to being cool, right? I mean, it's a little bit warm. It's providing some power, but not a ton. How strange. Okay, well, problem solved for now, so that's good. So now let's get on with installing this, I think is the next step. I think so. All right, well, let us unplug our cable here, and we'll take this back over to the micro stage. Guess I'll get these hooked back up first. Let's see, that's gonna be like that. So we're gonna hook this up. We'll do one of our clippy hookies, two of our clippy hookies, and we discovered last time, which I love, we can do a third clippy hooky just there. And so when we, let's see, can I get this? That's gonna be there. So we'll go 1, 2, 3. So that's our batten in place. Now we'll get our control unit clipped in, and there's our drop hardware in place. Here, let me adjust some lighting for all of this, and we'll adjust our point of view. Wow, sorry, I'm just gonna fling your point of view all over the place here. Apologies. This is one of the things I was hoping to solve with a new camera solution before tonight, but you know, I hope with a lot of things. All right, so let's get this nice and centered up and relatively plumb. There we go, something like that. All right, that could be worse. So now I'm gonna move a couple things out of the way. And hopefully we'll get ready for a drop, if all goes well. So let's see, what I did earlier was I made use of the 4-pin connector here to sort of hold our control board in place, by sort of connecting my 4-pin header through the truss members. That sort of holds that there, and hopefully if I run this, we should still have, yeah, we still have our hook control there. It'd be nice to have a slightly bigger, wider viewpoint here. Let's just bring that back. Bring some light down there. All right, so now let me get the hook set up. I'm gonna hook this a little higher up than I would normally, and we'll grab our curtain. I mean, this is gonna be the moment of truth, really. Chris says, don't you have the idea of like adjusting lights by hand? I know it's sort of anathema to the whole point of the Demilight project, but all right. So now we can hook our curtain on. Maybe want to shorten this curtain up. I also don't know that these grommets are the perfect solution. They just happen to be, you know, on this shower curtain. Yeah, that's a curtain. I guess we could come a little closer. Yeah, that's our curtain. Curtain is backwards, is it? You're backwards. Is it really backwards? I guess I don't know which side is front and which side is back on that one. All right, well, before we do this drop, I think I've earned a little refreshment moment, and then we'll give this a try. Oh, I see. Chris was trolling me. Thanks, Chris. See, I was all ready to believe you. You've built so much trust with your good advice over the weeks, Chris, and you've thrown it all away. So I have no idea if this is going to work or not. If it does, I'll be tremendously excited. I'm going to have another victory sip. If it doesn't, we'll figure out why. we'll see what happens. Yeah? Shall we do the thing? You know what we should do? So if this does work, I will make up a little splitter block for my DMX line going in here, so we could have this drop with NeoPixels lit up, with the truss warmers lit up in the truss while we do it, because I think that would look quite cool. But should we just test the curtain? Let me see which way this is. So down is drop. Okay. Well, in theory, 3, 2, 1. I was afraid of that. Yeah, so because of the spacing between the grommets and, like, the hook is not big enough really for these grommets. So it kind of got hung up there. Well, anticlimactic, but that's all right. If this worked well the first time, it wouldn't be my stream. Oh yeah, with the truss warmers blocked by the PCB. Yeah, you make a good point there, Chris. We'll have to do some more rearranging. Let's see. First, though, let's get this curtain working. I think the first thing I'm going to do is just trim the top of the curtain down here, just so it's nice and flush with. Trying to make 3D printed grommets, says Chris. I could. I'm also so I have a really nice grommet kit at work. So if this works, right now, I was literally at Menards yesterday and I was like, oh, a curtain with grommets. Well, that would be a handy thing to just, start with. Assuming this works, we could get much more specific about spacing and things like that. Within, and maybe a nicer piece of fabric that's not, a shower curtain. Maybe some like purple China silk or something really classy. Not to rip off Six the Musical at all, but I think a purple China silk kabuki drop would be pretty cool. All right, so that's trimmed down a little bit there. Let's go for a take 2. All right, and 3, 2, 1. Hey! It did the thing. It fell. Hey, that's exciting. Oh, yay. Oh, it worked. Second time's the charm. Let's do that again. Part of, I think, the other thing that's happening here is, it's a relatively lightweight curtain. It's a relatively short curtain, and it's both short in terms of width and in terms of height. And so there's not actually a ton of weight to pull this thing off of its hooks. Yeah, exactly. I see Thomas, yes, I need a pipe on the bottom for weight. So like it doesn't have a whole lot of oomph to get the things like started. So the fact that it's falling at all, I'm actually quite delighted by. Should we do it again? Let's do it again and then think about what comes next. All right, 3, 2, 1. Hey! So what happened there, the curtain, because it's falling just a little bit down to this lower desk shelf here, it fell like 2 inches and then sort of got, bunched up on itself like a shower curtain does, and then just toppled over. Yeah, so not a perfect curtain by any stretch, or a perfect setup. But I'm excited that it works. It works. The Kabuki works. That's awesome. How cool. All right, well, let's get a splitter board rigged up so we can do this with some truss warmers in place. And I think the more sensible place to do it is, I think I've showed this off before, is back over here. This is the board that's currently running the truss warmers. So I think what I'm going to do is actually just mount a splitter board there in the back that could run to multiple trusses, and then we'll take a little 4-pin jumper and run it to the Kabuki control board. I think at one point I had said I was going to rotate this whole mechanism 180 degrees so this controller was in the on the stage right side here, if you will. But I actually like it being over here, stage left, which is closer to me, just because it makes it a little bit easier to work on. Oh yeah, Chris, I jumped the GO. I'm so sorry. My dead man switch failed. Lot of process revisions we'll need to think about here. I have a story, not a short story, but you should know better by now about Kabuki drops and safeties that I can tell as we assemble this next splitter board here and get those truss warmers back up. But let me grab the parts. Let me grab parts first, and then I'll tell the story as we assemble. Let's see. So I am looking for PCBs for my distribution board. But they're not in my Big Bin O PCB. Oh, here we are. Yes, they are. splitter board there, and we're going to need now, I guess the other question is, do I have enough Phoenix terminals still to make this happen? Because if memory serves, we are running out. I have one. Let's see if I have a second. Because I'll need 3 to do this properly. I might not, actually. Let's see, I have one of the connector ends there. Let's look in our assembly parts bin. Let's see if that has sufficient. If not, I mean, we can scavenge from my test fixtures bin, which actually I might have a assembled board in there already. But what I need is the solder to the PCB part, which I burned through at a tremendous rate, making and breaking these Demilight boards. So we shall see. Let's see here. Can you hear me? Hopefully so. Testing, 1, 2, 3. I got a little over vigorous reaching back here, and I yanked my audio interface clean off my desk, and it came unplugged. Now, according to my meters, you can still hear me, although I can no longer hear those sweet, sweet tunes. Let's see. Oh, wow. This is not what I was looking for, but these are some blast from the past things here in my test fixtures bin that we'll have to have a good laugh about. Yeah, it doesn't look like I have any more of these solder-in Phoenix terminal parts. But that's all right. Yeah, Chris can hear? Okay, great. Yeah, so this is what I found in that bin. This was the original generation of splitter connector, right, which has DMX hardwired input here, a screw terminal there, and then just like solder pads, just through solder pads for that wire connection before we were doing Phoenix connectors, which is a wild time. Chris has a lot of DIN rail connectors. Oh yeah, I just have a big block of DIN rail connectors in that test fixtures box, just because they're really useful for when you don't know what kind of things you're gonna have to wire together. For years, that lived in my consulting toolbox. It's like go out to a site and be like, hey, can you get some DMX into this? And with enough DIN rail, enough bits of scraps of wire, you can get a lot of things connected to a lot of things. Oh no, this is generation 1. Look at that. That's that same PCB. This is not the same PCB at all as the current generation splitter injector. Huh. That's wild. Well, you know what I could do is I have an existing power splitter injector just here. What I might do is just... What would make any sense? Really, I should have made this cable longer. Because I want this board here to be over at the microstage itself. But I made this a hardwired Phoenix 4-pin to XLR connector. So I might just make this longer and reuse this board for now. That would make a good bit of sense. And really what I need to do is reorder the Phoenix connectors. Wire nuts and longer cable? Well, yeah, it would certainly be an option. I mean, I could branch off. Maybe I'll just make another long 4-pin jumper, and we'll go from here over to the microstage as well. Because then, they'll be a little bit silly, but I don't hate the idea of having another 3-foot 4-wire jumper around. Actually, no, I take it back. You know what I'm going to do is I'm going to reuse this 4-pin jumper that we've been using to run from the DMX on the board over to the microstation. I'm just going to put a little 2-for jumper into these terminals. I think that'll work quite well. Let's see here. What I do, I'm just going to real quick just double check. Now I'm a little scared of the audio shenanigans. Hopefully everything is still sounding okay. I am just going to double check in my settings here that everything is the way that I think it should be. General, okay, that looks fine. Let's check some audio properties just to double check that looks fine. Okay, well, if it sounds good to you and it looks good to me, it probably is okay. let's see. Yeah, it's almost so the Demilight code itself is very, very short. A lot of the hard work of that is done behind the scenes in what was the Conceptinetics and is now the JDMX library, right? So anything to do with processing DMX frames, sending them in or out, RDM messaging, receiving, and the beta version of the sending library, like that's all just buried away in the library. So ultimately, right, the DMX code or the Demilight code for, make a basic moving light with 3 channels is read 3 do some setup, read 3 addresses of DMX, one of which is intensity, one of which is pan, one of which is tilt, send those out to PWM and 2 servos, and you're done, right? It's like an address for pan, an address for tilt, an address for bright, and everything else is handled inside that library code. And that library is like 1,200, 1,400 lines of code, right? But, from an end user perspective, which is a delightful place to be most of the time, it gets to be just, a little bit of user code at the end of the day. App that I wrote to convert UDP OSC to TCP OSC. Ooh, that's fun. That's a nifty little utility there, Broke Both. Let's see here. I was going to, let me double check my pinout. RGBW, yes. So obviously the color coding here is arbitrary in terms of which wires corresponds to which parts of the signal. And so just for my memory's sake, I have decided that the correct order to go into my 4-pin Phoenix connector is from left to right, like we'd read here in the States, RGBW. So red, then green, then blue, then white, which means red is positive voltage, green is DMX data minus, DMX data plus, blue is DMX data inverted, and white is ground. And so the color coding ends up not making a ton of sense in terms of its relation to any other DC color coding. But in terms of being able to successfully recreate that color code on the fly, having it be RGBW left to right actually makes my life really quite a bit easier. Lines of code makes me think you're just prodding me for stories at this point. Let's see, where do I start? The project I'm currently working on at work, or one of the 17 projects, of course, is this program called that I wrote called Show Player, which I think I've talked about or showed off a little bit before, especially back when we were doing a more class-like structure on these streams. We were talking about Python and Raspberry Pis and things. And basically to do the automation control on the 727 that's hanging up at the museum, up until about a year ago, it was running literally on a program running on DOS 6.1 that would boot up to the shell and say, "Hello, Bill," who was the engineer who wrote it back in the day, and then would sort of do everything under DOS prompts. And I decided that since we're upgrading that exhibit anyway, we could do a little bit better. So I've been writing a control program that runs under tkinter in Python, so it's got a GUI built in to do that automation control. It's functional. It's running the automation now, but one of the features that we would have had pre-COVID is we have a slew of volunteer current and former pilots who come to the museum and talk to guests about the plane and about being a pilot. And especially a lot of them, like a lot of the folks who volunteer for the museum, although not always, are people who are retired, right? And are just excited to share their love of science and technology with, a lot of younger people. And that's really cool. And so a lot of these are folks who, the plane was built in 1963. It came to the museum in the early 90s. And so a lot of these are pilots who, either flew 727s much like this in their professional careers or still do, which is really cool. So one of the things they do as part of the explanatory process is we had these automation controls set up not just so right now they run through a predefined sequence of movements every half hour on the half hour, right? It's so the landing gear lowers and then the lights come on, and then it waits 8 seconds, and then the flaps lower halfway, and then it waits 4 seconds, and they lower further, and so on. And then when it's done, it just resets itself sort of back to its all closed and off position, and then a half hour later, it runs it again, right? Nothing terribly fancy. One of the features that we had pre-COVID is the volunteer pilots would have a little RF remote control so that they could step through the various parts of the show at their own speed. And they had a little... I honestly never experienced it myself. I wasn't there that long pre-COVID. But they would, say, and the plane has... to the landing gear alone weigh 3 tons, and you click the button and the landing gear comes down. And as we're getting ready to land, we need to increase the wing surface area, and we use things called flaps, and they click the button and the flaps come down, and so on and so forth. And so I've been integrating that manual control back into the control program that I've written to allow it to either be automated or step through manually. Wow, this is not what I intended to do. Exactly, I meant to not put these into a new connector. I actually want to put these into the same sort of... is that true? No, yes, that's what I want to do. I'm just going to make a 2-for connector here. And so that's been a lot of fun. For the input device, I ran across... So where my mind goes to, right, it's a relatively simple program. It just needs to sense whether there's essentially a contact closure input to a PC, right? And so there are any number of data acquisition devices out there that are designed for this. Everything from, little inexpensive modules to, Rockwell, of course, makes the several $1,000 version that you want running your factory line, and we want to be somewhere in the middle, right? Like, I'd like not to spend $3,000 on it. I can afford to spend more than $20 on it. So we ordered like the $80, semi-name brand model. But one of the products that I found, and I asked my boss to order just because it seems really useful, is, and as I finish wiring this up correctly this time, we should go just take a look at it. If you go to Amazon and search for data acquisition device, or USB data acquisition, there are a number of manufacturers, all cheap overseas manufacturing ripping each other off, that make a device which it's an STM32 microcontroller and a C430 or a CH430 USB to serial adapter chip, that is a little 10-channel ADC board over USB. So you get 10 channels of, I think, 10-bit ADC over USB, and I think the default is it samples every half second, and just shoots that information over the USB connection as a serial port to the host computer. So if you were doing any kind of like really rudimentary testing or data logging, the sample timing is configurable, although their method for updating the firmware to make that happen is not super convenient, although it is in theory doable over USB. I haven't tried it yet. Like, just these little like $20 devices with 10 ADCs on them is a really nifty little thing, like for doing data logging or voltage logging or weather station measurement or something like that. Anyway, I don't have a project in mind for them yet. I was just really jazzed about the cheapness of these little modules here. Before we plug this back in, let me show you what I'm thinking of. We'll go over to this monitor. We go to Amazon. We say DAC USB. Not quite. What is the data acquisition USB? Here we go. This little guy. The Noito USB 10-channel. Oh, it's 12-bit analog to digital converters, right? And $18, like super duper cheap. And it seems to work pretty well. You also get a hardware serial connection on it if you want it. So I was like, there must be something fun to do with 10, 12-bit analog to digital conversion channels that you can hook straight to your computer. That sounds like a recipe for making a musical instrument out of that hooks up to some script on your computer or something. Anyway, I just thought that was a super neat thing. So if someone's looking for a next nifty project, I would propose that as an interesting option. So now that we've got our cable built, let us plug things back in. So we'll plug this. As Chris pointed out, I'm going to move my little control board. so it's not in the way. Let's see, maybe I can kind of stick it on top of my Kabuki controller here. I might have to jettison this additional stabilizing hook just for the sake of space. There we go. Or maybe I can kind of trap the control board on top here with that hook. Maybe? That kind of worked. It's not, that's not incredibly janky or anything. Now we'll hook up our truss warmers and we'll turn our power back on and we'll see, hey, there we go. So let's, now of course, because this is, the Kabuki drop itself is address 12, which is also the blue channel of my second truss warmer there, I don't have totally independent control of it, but that's all right. Let's do red, and here, let's adjust our lighting a little bit. Do that, and we'll get our curtain back in place. Yeah, so, of course, as we trigger the Kabuki drop, that purple is going to change to red, but that'll be okay. And we'll get that hooked back up there. That's 1, 2. This is not the easiest thing to rig, but that kind of mirrors the experiences I've had with full-scale Kabuki drops. But they can be a little bit finicky to hang. Okay, so there's that guy set up again. Ah! All right, now we have our tasteful drop there. And maybe we'll change the color on that guy. Yeah. Should we? I'm gonna drop it one more time. Why not? I mean, it's just wild, right? I mean, other than the shenanigans of my power supply burning up a buck converter on the control board, this has gone surprisingly smoothly tonight, which I'm kind of delighted by. Kabuki needs 16-bit preservation on that servo. So the servo, Thomas, let me drop the curtain, and then let me yak at you about servo precision. All right, should we drop it? 3, 2, 1. Oh no! No! Oh, almost. Yeah, you know what would be a great fix? So these are just basic shower curtain grommets, right? I want a thinner walled grommet. Or you know what I could do is make those hooks a little bit bigger. And honestly, in general, like that's kind of an arbitrarily small amount of space. I could just make this hook twice as big and it would work just as well. Or, as Chris says, a lead curtain, or something with a little bit more weight to it. I'm still having this flicker in the NeoPixels, which I do still think is a timing issue in my library, right, where it's trying to update the DMX reception in the middle of a frame of sending out NeoPixel data occasionally, and that's why we're seeing those flickers. I think that's what's happening. I have not confirmed that. Let's try this again. Maybe, you know what I'm going to do? I'll give you, if you will, a little view behind the curtain. I'm just going to reach down off camera here. Not that it really matters. I don't know what. It doesn't really matter. I'm like, I'm going to do something secret off camera. Who cares? But off camera, I'm just going to apply a little bit of downward force on the curtain itself just to make it a little bit more likely to fall. 3, 2, 1, go. Hey! There it goes. I also probably could use some cable dressing here, huh? Oh, that's very exciting. Oh, okay. So the micro stage is coming along, right? It's got some soft goods that deliberately fall down. You got some truss warmers. I need to do a second set of truss warmers here, and I now have the hardware for a third truss. I'd love to do a sort of upstage most electric. I gotta continue to think about how to get this all on camera in a way that's not quite as crunchy, but that'll be a fun thing to do. So the thing about, so Thomas of course is working on a small but like significantly larger homemade moving light. One of the things that's true about, because I'm working with these little tiny hobby servos for all of this, he said, trying to pick one up off the table and realizing he's used a bunch of them, which is a good thing. Oh, here we go. Right, we're working with little tiny hobby servos. And the theory of operation for these, and we've talked about this before, right? Is you're sending a pulse width modulation signal of a type down the signal wire of these. If that signal is, I think, 1,000 microseconds wide, is the default. That is, corresponds to a 100% clockwise rotation. 2,000 microseconds or 2 milliseconds wide corresponds to a fully counterclockwise rotation, and anywhere proportionally in the middle corresponds to an intermediate angle, right? There is a certain amount of deliberate imprecision in that placement. As for a typical hobby servo like this, it's about 50 microseconds. So that is so that, like, you know, if the comparator that's comparing the length of that pulse to the current position of the servo at one moment sees a pulse that is, you know, 1,342 microseconds long, and the next one is 1,343 microseconds long, it's not constantly trying to, like, hone in on a level of precision that our signals are just not going to have. So you really only have, you know, when you think about that, if you have 50 microseconds of precision and you have 50 microseconds of equivalent precision and you have 1,000 microseconds of controllable range, you really only have about 200 recreatable positions of this servo. Now that's not quite exactly how it's working under the hood. It's not like it's going to one of 200 set positions. It is in fact going to the position that is its best guess from the last time it changed and not changing that position again until your signal length deviates by more than plus or minus 25 microseconds from the current pulse length, right? So you establish essentially a new bucket of position each time you move to a new major position. But that said, this is all my way of saying not a lot of point in going to 16-bit on a servo that has less than 8 bits of precision in and of itself. But there we are. Yeah. So as the, like, summary bar explains in the bottom, there's more work to be done on this Kabuki, and certainly there will. But I'm super stoked that it is working and dropping things most of the time, and it could be ready for a new exciting curtain. Like, that's an awesome development. So more to come there. Things happening next in Demilight Land, and if I'm curious to hear what people are themselves working on or excited about. I think I need to get back to the proper lights, right? It's been a month since we've really worked on the Demilight itself, and I have a bunch of parts printed and a bunch of things. I do still need to, like, finalize the next generation of boards and get them on my way. I'm just, like, I think I said this before, I've just been, like, putting them off because it's the same kind of, like, specking and project energy I've been using in all of my other work. So I've been excited about this mini Kabuki project because it's it's really different from anything else that I've got going on in my life right now. But I'm also feeling like the lack of progress on the Tiny Moving Light project, and so I think that'll be a fun thing to return to, at least for a little bit. So that's, I think, where we're going to be next week, is getting the plot, which currently, well, I've taken all of the lights down from the micro stage, but I do want to start populating the stage with more fixtures. Also working on things like Chris says, like cable management, and, you know, power distribution through all this in a more cromulent way. And then maybe doing some, like, aesthetic touch-ups, like give ourselves a nice clean background here to work with. Maybe move the bat phone somewhere a little bit different. Also fix the bat phone. So the phones themselves are still working, but their ringers are not. So I think I have a power supply issue in my ATA, my analog telephone adapter that's strapped to the wall over here. That's causing the ring voltage not to be successfully generated. Because the rest of the circuitry, I can make calls, I can receive calls, but the phones don't ring. So, not... I mean, I can receive calls if someone... Like, literally, I had a friend who tried to call me on thing, and then called me and was like, hey, your phones aren't working. Pick up your phone right now. And I picked it up, and it was fine. But the ringers don't work, so not a terribly good feature. So... yeah, more mini lights to come, more soft goods and more dressing here. I also, I didn't bring it in here. So I think I mentioned last week I have a new light board. And by new, I mean it was something that came up on, so our neighborhood in Chicago has a free box. And lots of neighborhoods have this, lots of cities and towns now too. It's like local to our little neighborhood. It's like, hey, I have 6 pint glasses. that I'm not going to Craigslist them, and I could donate them, but like, does anyone just want to come by and pick up these 6 pint glasses, or this chicken-shaped cookie holder, or these baby clothes that my kid has outgrown? It's just like nothing is allowed to be sold. It's just like giving and taking and like passing things around for the good of the community. And on this free box, someone was like, does anyone want this light board? Yeah. It's an American DJ product. It's a Scene Setter 48. So it's, you know, it's a relatively chunky thing, but I have to make some room for it. But it's like the big sibling version of my little knockoff Chauvet controller, 48 faders, and it has an effects engine built in, and a very simple effects engine. But I think that'll be a really handy thing. I'm thinking it maybe lives, if you can see, so this is like my secondary workbench here. I think maybe that the new light board lives down underneath it on a little extra shelf. There's just an easy way to, you know, have some effects and presets and things running, you know, keeping things interesting up here. Oh, hey, Kenneth. Kenneth says just keep picking up the phone to see if someone is calling. Yeah, for sure. Yeah, let's just, oh, now I don't even have a dial tone. Oh, that is new. Okay, in the last 3 or 4 days, used to be I would have dial tone, I just didn't have ring, and now I have neither. Let's see, actually, let me see if I have dial tone on the office phone. No. Yeah, something has gone screwy. I think maybe in the power supply that I'm using to power the ATA, something is not right. Something is quite wrong. Good to see it, Kenneth. That wall has voltage problems? Yeah, for sure. Hey, Kenneth, as long as you're here, as we sort of head toward the end of the thing, here's a weird thing that happened tonight. And Kenneth, okay, if I can tell a little story, Kenneth is the person that I call when I'm like, this is a totally bizarre problem. I wonder who's seen this before. Let me call Kenneth. The thing we discovered earlier tonight is, so I moved one of our little Demilight control boards with the buck converter module on it from the lab power supply over to the 12-volt Meanwell power supply that I use to power like the LED lights and things in here. And it caused the buck converter to have intermittent failures. Like it seemed like it was browning out every few seconds. And it was getting incredibly hot, like hotter than hotter than I would expect. Not like burning your skin hot, but like uncomfortably so. And so I theorized that, it's a really highfalutin word for guest, that the Meanwell power supply was interacting with the little shitty buck converter modules in a way that was causing them to overheat, to not be able to regulate their voltage correctly. So we're back on the lab power supply to power things for the rest of the night, but I wasn't sure if that kind of interaction between what should be, admittedly, a switching power supply, but nothing fancy, and a buck converter module is something that you've run across before. Because as someone who has run across, like, sacrificial anode issues and chemical mishaps in water and liquids, you know, if anybody, I thought you might be the person to. But that's just, maybe it's also certainly possible, like, this is as I was saying earlier, this is a 60-cent module. So it could also just be that they're crap. But if they are, I'm going to want to quantify that a little bit, because this is the module I've been like sort of recommending to people. Ken says, oh yeah, 125 kilohertz is a standard SMPS frequency on lots of power supplies. Well, that's a term I don't know. SMPS, let me guess, super mega power standard frequency. I'm gonna guess. So one thing I could certainly do the experiment to check is, as I mentioned earlier, that the thing I started with, if I pull out my, I make a mess here. Let's see, I have my, so it was right. So originally we started with just linear converters, actual 7805s. And then we went to, and I'm just trying to find them in the big bin of parts here. PCBs. I might have moved these over to the assembly parts bin, but with some actual like proper power buck converter components from DigiKey that were expensive. Does the bad module work on a linear supply? Not sure, because I guessed wrong. I swapped the module first. This is actually the module that was causing problems. Swapped the module, plugged the board with a new power module into the switching supply, was seeing the same symptoms, so turned it off, moved it back over to the regulated supply, the linear supply, and it worked fine. So I guess I don't know if this specific one that was overheating for so long would work on the linear supply, but the identical and not overheated module works fine on the linear supply. So, anyway, so there's that. So maybe a linear power supply is strongly preferred, or maybe there's some, I don't know, if applying some like bulk power factor correction would help, like doing some bulk capacitance on the line. Although maybe that exacerbates the issue, right? Because the whole issue is that it's a reactive circuit. Make a switching supply look more like or maybe we go theater old school and put a ghost load, a 12-volt ghost load on the line and see if that helps anything. We shall see. Well, with the apply more filtering, yeah, we could put a choke on it. We could put some additional filtering caps. We could add some resistive loading maybe as part of that filtering. Yeah, lots of good things to experiment with. More things to test and destroy in our future, I think, which would be a lot of fun. But for tonight, I mean, other than the issues where things didn't work and started to overheat and burn oneself a little bit, pretty successful night, right? This every little improvement makes this feel more and more like things are taking shape, which is pretty exciting. And obviously, there's still some mess to clean up here, but yeah, I'm really stoked. This thing is really coming along. As it can, the switch mode regulators have better loop control when there's a minimum load. Yeah, for sure. So thankfully, I have a polyphony of 12-volt little bulbs and other linear loads, resistive loads from all the theater work over the years. So maybe we'll slap a few of them on there as a ghost load, or maybe just some power resistors. Now that I come to say it out loud. But that can be a project, I think, for another time. I think we're gonna wrap. It's not even 2 hours in tonight, but I feel like we're just gonna wrap it up. This has been great. Thanks, y'all. Thank you all. Thank you, especially Thomas. Thank you for all of your contributions so far and in the future to the Kabuki project. The Thomas Coupler will forever be named after you in your honor, because it works really quite well, and I'm excited to, if you're all right with it, share it with people, because I think it's a really neat part. I think it's going to be a useful thing for attaching both our scale battens to each other and battens to servo. So thank you for that. Thanks for everyone for stopping by. Dave, good to see you. Chris and Kenneth, always good. Thank you for your advice. Cookie, I'm sorry I couldn't burn myself any more tonight, but I'm doing what I can. Jeff Sachs, if you're still out there, I hope we'll get some more drill sounds in here for the future. And anyone else who's just hanging out there, no one is ever required to chime in, but it's nice to share these evenings with you all. I hope you are staying safe. I hope you are washing your hands. I hope you are drinking lots of water and being good people. And I say this every week, but it is a privilege to be here, to have the time to be here on these Sunday nights. And yeah, it's just great to see all y'all and share the successes. And more often than not, the failures, and if nothing else, the stories. It is fun to share with you on these Sunday nights. So thanks, y'all. I'll see you, if like, subscribe, thumbnail, hit the thumbs up, follow the Twitter at the Jeffers Glass, all the good things. Brokepo, thank you, as always. Brokepo, always fascinating to hear what you're up to and your experiences in programming and coding as well. Yeah, do all the good things. Be good people. You know what to do. I'll see you next week.